Hi, today we'll be going over the sorting algorithm bubble sort, its characteristics, a demonstration, and the implementation for the code. Bubble sort. Sorts by comparing each element in a list, swapping items if necessary, and repeating the pass through the list until no swaps are done. It takes as a parameter an array A, which we will define later. Bubble sort has the complexity of big O n squared, which means it works okay for small amounts of data, but not bigger ones. Here's the algorithm. In the algorithm, there are two for loops. The length of the internal for loop changes the more iterations there are of the external one. The internal for loop also has an if statement. The if statement will swap two numbers if a at j is greater than a at j plus 1. Here is a visual representation of what happens when we use bubble sort. We've initialized an array A with the numbers 23, 15, 1, 15, 30, 8, and 3. Next, we'll initialize I and j to 0. This means j plus 1 will be equal to 1. So we ask ourselves, if a at j is greater than a at j plus 1, then we swap. So, is 23 greater than 15? True, it is. This means that we swap, which can be seen from lines 5 to 8. We set temp to a at j, which is 23, a at j, which is a at 0, is equal to a at j plus 1, which is 15, and a at j plus 1 is set to the temp, which is 23. We successfully swap and increment j. Now we ask ourselves the same question. Is a at j greater than a at j plus 1? Or is 23 greater than 1? True. This means that we will swap. Temp will be set to 23, a at 1 will be set to 1, and a at 2 will be set to temp. We swap, then increment j, and now we ask the same question. Is 23 greater than 15? True. This means we swap and increment j. Now we have the question, is 23 greater than 30? False. It is not. So we don't swap, but still increment j. Moving forward, we have the question, is 30 greater than 8? True, which means we will swap and increment j. Now we have the same question, is 30 greater than 3? True, which means we swap. Now you can see why it is called bubble sort. The largest bubble floats to the top being index 6. As you can see on line 3, the internal for loop only runs for a.length minus 1 minus I. Now that we're done with the first iteration for j, that means I will iterate once, a, meaning number 6 will become grayed out, since we can no longer access it. Here is an example for the rest of the code. We ask ourselves, is 15 greater than 1? True. This means we swap, and j moves forward. Is 15 greater than 15? Not really, so j moves forward. Is 15 greater than 23? False, so we move forward. Is 23 greater than 8? True. So we swap and move forward. Is 23 greater than 3? True. So we swap. That iteration for j is done. I increments, and that spot becomes gray. Moving back to the beginning, we have, is I greater than 15? False. We move forward. Is 15 greater than 15? False. We move forward. Is 15 greater than 8? True. So we swap, then move forward. Is 15 greater than 3? True. So we swap, gray out, and move back to the beginning. Is 1 greater than 15? False. So we move forward. Is 15 greater than 8? True. So we swap, move forward. Is 15 greater than 3? True. Swap, gray out, back to the beginning. Is 1 greater than 8? False. Is 8 greater than 3? True. Swap, back to the beginning. Is 1 greater than 3? False. So it stays there, becomes grayed out, and so does 1. This means that the array is sorted. Now we will move into the coding implementation. And now we're going to start with the implementation for the code. First, I'll make a class called bubble. Next, I'll make the main. Now I'll save it to the correct directory. And now I can initialize our array. Now I'm going to create a method called bubble sort. And this will be a void method since we are not returning any values. This method will take an int array as its parameter. Now we can create the external for loop. And now we can create the internal for loop, or otherwise known as a nested for loop. And remember that this length must also minus I. Now inside of here, we will have our if structure. If a at j is greater than a at j plus 1, then we will swap. In order to swap smoothly and not lose any variables, you need to make sure that you have a temp. After taking the value from a at j, now we need to assign a at j equal to a at j plus 1. Since the value at a at j is greater than a at j plus 1, now we will move a at j plus 1 to where a was before. This means that we are moving it down the line, while a at j moves up. Now that that is done, we need to call our method. Since the method is a void, we don't need anything else but to call it itself and pass on the array. This means once it's done with the method call, the array will be in order. In order to see that, we can go ahead and print it. Make sure to put a space in there so that you can see the numbers clearly. And since I want all the numbers to be on the same line, I will remove the ln and add a system out print ln over here. Now I go ahead and save and compile. Now when I run it, it should print out the array in order. Ha! I accidentally put the wrong sign. I see what I did wrong. I forgot to say a at j plus 1 is equal to the temp. Let me go ahead and save it, compile it, and there it is in order. At this point, you've pretty much completed everything you can do with bubble sort, but if you also want to see each variable float to the top, we can also print out right here. Remove the ln, a at j, plus a space, and then system out in the external for loop. This is included in the internal for loop. You can see by the curly brackets highlighting. And then this is enclosed in the external for loop. You can see how this curly bracket highlights this curly bracket. Go ahead and save, compile, and run. You can see it was just like the animation. Each thing moved to the top and grayed out until we got to the bottom, where there was nothing left, and now we have them in order.